What's up everybody, Aditya Mahajan here and welcome back to yet another YouTube video. In today's video, we'll be looking at top Android interview questions and the site we'll be referring for that is InterviewBet. I'll share this link in the description. Now they have compiled a set of 38 questions which are distributed in three categories, that is easy, which could be asked to freshers, then the intermediate questions, and then finally the advanced question which could be asked to experienced professionals who are giving the interviews. Now, the reason I'm making this video is while I used to revise for questions, I would start reading and then procrastinate and waste a lot of time. Due to which I thought, like, if it was compiled in a video, then it would definitely help me in streamlining the process and I would not waste a lot of time. So without a further ado, let's get started. The Android is an open source operating system developed by Andy Rubin, and it is Linux based, and developers can do simple and complex functions with that. Now, if you look at the components of the Android application, that is its architecture has following four components. First is the services, which can be used to run background functionalities like downloading a particular file. Next thing what we have is activities, which are basically the GUI or graphical user interface where user can interact, and that could be anything like dialing a phone or viewing an email. Third thing what we have is broadcast receivers, which are basically used for listening to the system events. It could be like a phone call or SMS, etc. The final and the fourth thing is content providers. These are used to share data between various applications. Now, if we look at scope of Android in India, there are a lot of Android applications and various platforms where applications could be downloaded to provide you different services, which are as follows. And one thing that is not mentioned here is a Play Store. I'm not sure why. So let us look at the advantages of operating system. The first major advantage is that it is an open source. That means it does not have license. We do not require development or distribution fee. Okay, next thing is platform independent. When we say platform independent, we mean that development is platform independent, not the apps developed with it. Okay, so which means that Android Studio and Android SDK can be used in Mac, Windows or Linux. Next thing is we have highly optimized virtual machines. That is, earlier we used a Dalvik virtual machine, which has been converted to ART, which is Android runtime, and these are used to execute Android apps from Lollipop version, that is 5.0, which is API level 20. It also supports various technologies like camera, Bluetooth, speech, Wi-Fi, etc. Now, there are lots of applications available to download. While this being a pro, it can also be a con that there are a lot of fake applications also on the Play Store or any of the platform which could be used your data, which could monitor your data and use for malicious content. Next is for streamlining issues, that is due to large variety of Android devices, they are present with different screens and dimensions, and even with different operating systems. So any application which might run smoothly and efficiently in one device may crash in another. Next thing is background processes. So earlier to 8.0, we did not have any limitations, or we could say there were less limitations for background services. But now they have limits, so we cannot freely use them as earlier. I mean, we can use them, but there are certain limits, because they use battery, and due to which we have limited battery, so we do not want to consume a lot of battery. Next is poor data connection. Due to background services, they might use internet, which could result in more usage of data and poor internet speed, so that can be annoying sometimes. Now let us start with the very basic questions, whereas the first one is what is Android, which is an open source operating system for mobile devices, and the applications execute within its own process and has its own instance of DVM or ART. Now, what are the features of Android architecture? So these are present in various layers in Android stack. That is, the main are operating system, middleware and application, whereas each layer provides different service to the layer just above it. Now there are basically 5 layers what we have. The first one is the Linux kernel, which is the very low level task that we have, that is the device drivers, device management, memory management, power and resources access. Next we have libraries. These are a set of libraries which are used for very basic functions like for browser engine, WebKit. Then we have libraries to play audio and video. Then we have for storing databases, and then SSL libraries which are used for internet security. Next, we have Android runtime. That is, these are the core libraries for DVM or ART, as this helps in running Android applications. So DVM is optimized for particularly mobile devices, and it is for fast performance and consume less memory. So DVM was replaced with ART, which was introduced to execute Android apps from Lollipop version 5.0. Next layer or next what we have is Android framework. It consists of Android APIs like user interface, resources, content providers, location telephony, and package managers. It is basically provides interfaces and classes which are used by Android, the new applications that we have. Now, finally, on the very top level, we have Android applications like the very basic inbuilt applications that we have, like home, games, contacts, settings, etc., which basically make use of Android runtime libraries and the framework. Okay. Next, what we have is what are the different languages that are used to build Android, whereas the most popular is Java, because this is the starting point for most of the people who are starting with Android development. Now there are various IDEs also available, that is Eclipse, NetBeans, IntelliJ, etc. Now we also used Kotlin because they provide modern and safe object-oriented way for cross-platform development. And other than that, we have C#, Python, and other programming languages as well. Next, we move on to a question like, let's say, what is an activity? So as we saw, activity in Java is basically a single screen, which is a GUI where user can interact to do any particular task. Okay. So for example, the example that they have given here is the Facebook start page where you enter email and password to log in to the application. So which is basically an activity. Next, moving on, we have service, and service is an application component which is used for running background tasks. So that could be relatively longer because we do not want to keep the activity in the background for long, which is why we use services. And it can run in background even if the application is switched to another or it has completely been closed. The services can run in background. Next question what we have is differentiate between activities and services. Now activities can be terminated or closed by users, whereas services are designed such that they are not dependent on activities and they can run in background or can be closed with activities. So if we tabulate those, then activities run in foreground, whereas services may run in foreground or can run in background as well. User interface is necessary for activities, whereas it is not for services, and activities are not independent, whereas services can act independently. Next question what we have is what is Google Android SDK and what are tools inside it. So Google Android SDK is basically a tool set used by developers to create new applications. The tools present inside them are first is Android emulator. This emulates the physical device, which would definitely use for testing. And we can emulate different API levels and different screen sizes, dimension, etc. with the Android emulator. So without needing to physically have them. Second thing is Android Debug Bridge, which is basically a bridge between the instance of the emulator and the application that we are using for debugging. So it is basically a command line utility to control the communication. Next is DDMS, which is Dalvik Debug Monitoring Services, and as the name suggests, it is a debugging tool which provides services like message formation, call spoofing, capturing screenshots, etc. Next we have is AAPT, which is Android Asset Packaging Tool, which is actually a build tool, and developers use this to view, create, and update zip compatible archives. Next question what we have is what is a bundle? What is the use of the bundle? So bundle is basically a asset kind of thing which is used to transfer data from different activities, and the data types can be anything. So the code snippet is as follows: we basically take a bundle and instantiate that, and we use whatever data type is present. So according to that, we use functions, we add the data and then put that into the intent where by which we can pass that data to different activities. Next question is what is an adapter in Android? So adapter acts as a bridge between adapter view and the data for the view in which we will be showing to the user in the activity. Now this holds the data and sends the data to the adapter view, and the view takes the data from adapter view and shows the data to various views like recycler view, spinner, list view, grid view, etc. Next thing is what is AAPT, which we just saw in Google Android SDK. So it is Android Asset Packaging Tool that gives developer to do the same thing, that is update, view, create, and it passes indexes, compiles the resources into binary format, which are basically optimized and will perform better for Android while running the applications for the users. Moving on to the next question, what is portable Wi-Fi hotspot? I'm not sure why they have added this question. It is basically for using mobile internet connection to the other Wi-Fi enabled devices. Next, what we have is Android Debug Bridge ADB, which we just saw in Google Android SDK. So it basically is a command line tool used to allow control communication with an emulator instance and gives power to the developers to execute remote shell commands and run application on it without having a physical device. Next is DDMS. It is also one of the Google Android SDK tool, and it is Dalvik debug monitor, so used for debugging. And it provides following features like port forwarding services, thread and heap information, logcat, screen capture, network traffic tracking, incoming call, SMS spoofing, and location data spoofing. What is AIDL? Which data types are supported by AIDL? Now, AIDL is Android Interface Definition Language, and it is a tool that handles interface requirement between a client and IPC, that is inter-process communication, to communicate at the same level. Now, the process involved dividing an object into primitives that is understood by Android operating system, and the data types that are supported by this is string, list, map, char sequence, and trivial data types that is int, long, char, and boolean. Next, moving on to the Android intermediate question. 15th question is, what is the life cycle of Android activity? So we'll look at all the functions that are being called one by one, and we'll finally look at the overview. First function that is called is onCreate, and when the activity is created, this function is called, and using this, the views are created and data is collected from the bundles. Next function is onStart, and if the activity is becoming visible to the user, then this onStart function is called, and it may be succeeded by onResume or onStop if it comes to foreground of or if it becomes hidden. After this, after onStart, we have onResume, and it is called when activity will start an interaction with the user. Now, if it is an onResume, then user can perform any function on that activity. Now, if the activity is moving to the background but hasn't been killed yet, in that case onPause is called, and the activity is no longer visible to the user, in that case onStop is called. Now, if the activity is finished or destroyed, in that case onDestroy is called, and if after destroying the activity or it has been stopped, then if it needs to be restarted, then onRestart is called. Okay, so when activity start, onCreate is called. We get that views are created and data is taken from bundles. After that, we have onStart, where it starts becoming visible to the user. OnResume, user can start interaction. Then if it is going into the background, onPause is called, and if from onPause it becomes again visible, onResume will be called. Okay, now if from onPause we are moving to the next activity, then onStop is called, and if that activity is destroyed, in that case onDestroy is called. But after onStop, if it is getting restarted, in that case onRestart is called, and it is followed by onStart. Okay, and once that process is killed, if we need to restart that activity again, then again onCreate is called. So that is basically the life cycle of the activity. Next, moving on, we have sensors in Android. Now, in Android devices, we have various built-in sensors to measure certain parameters like motion, orientation, through their accuracy. Now, the sensors can be both hardware or software based. Now, the categories of sensors are these three. First is a position, which is basically measuring the physical position of Android devices, and this has orientation and magnetometer sensors. Now, next type is motion sensors. These consist of gravitational, rotational activity, and acceleration sensors, which measure the rotation of devices or the acceleration. Next, we have environmental sensors. This include temperature, humidity, pressure, etc. Now, explain dialog boxes that are supported by Android. So, Android mainly supports 4 dialog boxes. The first one is, and also the major one, is alert dialog, and it supports 0 to 3 buttons with a list of selectable items and checkboxes which user can interact with. And after that, we can perform any particular action on the basis of buttons that are pressed. Now, it is used when user want to take a particular decision like yes or no, or we have to move from one activity to another, or whatever we want to do. Next dialog box is date picker dialog. It is used for selecting date, and time picker is used for selecting time. The last one is progress dialog, but it has been deprecated after API level 26. So it is an extension of alert dialog only, which is used to display the progress bar. We can also add buttons to it, but now it was deprecated as we are not allowing user to make interaction with the application. So for showing the progress, we can use other indicators such as progress bar, which is embedded in user interface of the application. Now, next question what we have is, what is AndroidManifest.xml file and why is it important? Now, this is one of the most important file, because once the application is started, this is the first file that a system comes to, and it knows various details. Like, this file contains information regarding application that the Android system must know before the codes are executed. It is essential for every Android application and is placed in root directory. Now, the functions that it performs is like provide a unique name to the Java package, describe various components of the activities, various components of application like activity, services, and other things. It also defines classes which will be implemented by the components. Moving on to the next question, we have what is an intent. Now, an intent is a messaging object used to request an action from other components of an application. It can be used to launch an activity, send SMS, send an email, display a web page, etc. Now, it shows notification message to the user from within an Android enabled device. It alerts the user of particular state that occurred. Now, there are two types of intents that we have. One is implicit intent, which is used to invoke system components. The second one is explicit intent, which is used to invoke the activity class. So, example of implicit intents are map geolocation, dial a call, launch website, etc. Now, explicit intents examples are start broadcast receivers, launch an activity, start background service, etc. Now, before moving on to the next question, I want to take one more question, that is explain difference between implicit and explicit intent. Now, the difference is as follows. Now, an explicit intent is that where you inform the system about the activity should handle this intent. So it is basically for the activity, right? Here the target component is directly defined and in the particular intent. So the code snippet is like we instantiate an intent with the activity that is the target, and we put if any extras need to be added in that particular intent, and we just call the start activity function with that particular intent. Now, in implicit intent, you declare that action you want to carry out. Further, the Android system will check which components are registered to handle that specific action based on the intent data. Now, here the target component is not defined in that particular intent. So we create an intent and we instantiate it by, let's say, for example, an action view, and we need to open a particular website. So we add the URI. So it basically would be interviewbit.com, and we just start that particular activity and we pass that intent. Okay, let's move on to the next question. What we have. What are the differences between class, file, and activity in Android? So the differences are as follows. That is, class is compiled form of .java file, and Android uses them to produce an executable APK file. The file is block of an arbitrary information or resource that is used for storing information, and it can be of any file type. And activity is the single screen that represent a GUI and for which the user can interact, like dial a phone, view email, etc. Now, what is a toast and write its syntax? So toast is simple message that pops up on the screen, and it is used to display the message regarding the status of an operation initiated by user, and covers only expanse of space required for the message, while the user's recent activity remain visible and interactive. Now, these fade in and fade out and do not take any interaction from the user. Okay, so the syntax is toast.make toast, and then we pass the context, that is project activity dot this, and then what is your message and what is the length it should be. So we have length long, length short, etc., and then we just call the show after that. Next question is, what is a context? Now, the context in Android is the context of current state of application or object. The context comes with services like giving access to database, preferences, and resolving resources, etc. Now, there are two types of context that we have. One is activity context, which is also called as sometimes local context, and second is application context. Now the activity context is attached to the life cycle of an activity, and it can be used when you are passing the context and scope of an activity, or you need context whose life cycle is attached to that particular context of the activity. So, and second is application context, and it is attached to the life cycle of application. And we use this whenever we need context whose life cycle is separate from the current context, and we are passing this context beyond the scope of the activity. So we generally and 99% use activity context, and in some cases where it is beyond the scope of activity, in that case we use application context. Moving on to the next question, that is, what is an ANR in Android? So, and what measures can you take to avoid that? So ANR is application not responding, that is a dialog box comes up, and this happens when the main thread within an application has become responsive for a long time. The conditions that it can, under the condition, what it could occur is there is no response for the input even after 5 seconds, or the broadcast receiver has not completed its execution within 10 seconds. Measures that you can take to avoid that is the lengthy database or networking operations should be performed on a separate thread, or we can also use intent service for background task intensive applications where it would help in lessening the pressure from the UI thread. Next question what we have is, what are troubleshooting techniques you can follow if an application is crashing frequently? So we can do basically two checks, that is compatibility check and memory management. Now some of the operating system are not compatible for a particular application, so that could be the case. Other thing that we can do is we can check for memory management things, that is some devices run any particular application very smoothly, whereas some have lesser processing power or memory management things are not proper. In that case this could occur. Next thing is that due to limited memory space on mobile devices, you can free up the memory space for the application to perform properly. Or other thing that you can do is delete the application's data, which would clear its cache memory and allow some free space and might boost the app's performance. Now moving on to the next question, question number 26. Explain different launch modes in Android. Okay, so we have 4 launch mode. We'll look at them one by one. First is the standard launch mode. Now this launch mode generates an activity's new instance in the task from which it is originated. It is possible to create several instances for same activity. So if we take an example of this, let's say our current stack is having 3 activities A, B and C. Now if we launch a activity B again, then a new in the standard launch, then a new instance would be created A, B, C and B. Okay, so this is very simple. Next we have is a single top. In this launch mode is similar to standard launch, except if there exists an activity's previous instance on the top of the stack, then a new instance will not be created. Now here one thing to note is top of the stack, but the intent will be sent to the activity's existing instance. For example, to understand this, let us take the current stack to be A, B and C, and if we launch activity B again in single top, in that case new instance would be created because B is not on the top of the stack. If we take another example, let's say current stack is ABC, and if we launch activity C again, in that case, in the single launch mode, in that case, the stack will remain same, that is ABC itself, because the activity that is being called is on the top of the stack. So the intent will be passed to the on new intent method. That's it. Third is a single task. This launch mode will create a new task and push a new instance to the task as the root. Okay, for example, suppose our current stack is A, B, C and D. Now if we are calling B activity again in single task mode, then the new stack would be A and B. Here the callback has been received on old instance, so activities C and D would be destroyed. The final is the single instance, which is very similar to single task launch mode, but the system doesn't support launching any new activities in the same task. In this situation where new activity is launched, it is launched in a separate task. Now, for example, suppose our current stack is ABC. Now, if we launch the activity D in the single instance, then what would happen is a new stack would be created. So our stacks would be ABC and D. Now, if you call an activity E again, not in single instance, then activity E would be added to the first stack. Okay, so it would be A, B, C and E, and our second stack would remain same. Now, if you again call activity D, then this it will call from same activity from the second stack and pass the intent to on new intent method. Okay, so that's different launch modes. First we have standard, where new instance is created every time activity is called. In single top, it is similar to standard. Only what happens is if top of the stack and the calling activity is same, no new instance is created. We just pass on an intent to on new intent method. In single task, what would happen is we'll create a new task and push new instance to task as the root. So let's say if we have A, B, C, D and we are calling B in single task, then we'll just have new stack to be A and B. Similarly, in single instance, whenever we call a new instance, in that case, a new stack would be created. And that's it. Moving on to the next question, question number 27. What are containers? So container are basically objects and widgets together based on specific items required and in what particular arrangement is needed. Now, container may hold labels, button, fields, or even child containers. Now, they have given some couple of examples. That is, if you need fields in left or right side, if you need buttons, OK or cancel, rest below the form, or and you need to flash the right side of the screen, and some other things. So, if you have several widgets, you would need a container to have a root element to place widgets inside. So, that's are some of the examples where you need containers. Now, Android also provide collection of view classes that serves as container for views. And these classes are called as layout, which are defined in the form of XML files and that cannot be changed by code during our execution. Now, the layout manager provided by Android SDK are a lot: linear, relative, frame, absolute, grid, and table layout. Okay. So next question, what we have is role of Dalvik in Android development. So Dalvik serves as a virtual machine and is responsible for running every Android application. So because of this, we have the ability to execute multiple instances of virtual machines efficiently through better memory management. Next question is what is the latest version of Android? List all Android versions. So the latest version of Android is Android 11, released in 2020. I think there is one more release, but let me know in the comment section below. So the most of these Android names are based on suites or deserts, and we also have different API levels, which are integers values, and which tail the API framework revision given API framework revision given by the version of that particular Android. So these are some of the names. So initial did not have any code name. Then we have Cupcake, Donut, Eclair, Froyo, etc. So till I think Marshmallow, these are the older devices and are not seen quite a lot in today's what we say in Firebase, Flags, or wherever you do analytics. These devices, these operating systems or API versions would not be seen. Whereas after Nougat, you can see these versions. Okay. So what all things were added, what all things were deprecated, or what were the main features, you can read it if you want. Now let's move on to a little bit more difficult questions. So the first question that we have is what are broadcast receiver and how are they implemented? So as we already saw, they are used for listening to the system level events, like it could be an incoming call, SMS, etc. by the host application. Now it is implemented by taking a subclass of broadcast receiver and each message is broadcasted as an intent object. Now for implementing that, we just write the receiver name, which extends the broadcast receiver, and then we have a method called as onReceive, which takes context and the intent. Next question, what we have is we need to look at the important file and folders used when we create a new Android application. So the first one is the app directory. It describes the basic characteristics of application and defines each of its components. Next, what we have is a Java directory, which basically contains all the source file depending on what language you have chosen, that is Java or Kotlin. Now, by default, there would be a main activity present, and again the same in Java or Kotlin, whatever you choose. Now you can create all activities in all the source files in here. They would be in Java or Kotlin, and all the code or all the basic logic behind the application would go here. Next folder we have is res, which is also termed as resources, and it will store the values of resources that are used in Android projects, which would include features like color, styles, or dimensions. Now they would be stored in XML files, so their names would also be styles.xml, strings.xml, colors, dimensions, etc. Now there is one more directory called as scripts, which would contain the auto-generated file that consists of various versioning names, that is compile SDK, build tool version, minimum SDK version, target SDK version, and quite a lot of other things. For example, the build.gradle is also a script file which is placed in the root directory, and it defines all the build configurations that would be applied to your model in your project. Next question, what we have is what is the difference between serializable and parcelable, and which is the best approach? Now, while developing the application, there could be various cases that we might need to transfer data from one activity to another. Now we cannot we definitely we do it with the intent object, but there are some actions needed to make that data suitable for transfer. So for that we have either serializable or pass label. So serializable is a standard Java interface. In this approach, we just mark that class serializable by implementing the interface, and Java automatically serializes it by converting it into a string, and it becomes easier to handle it. Now reflection is used in serialization, and during this process a lot of objects are created, due to which there is a lot of garbage collection, which results in poor performance. Now in parcelable, it is an Android specific interface, and in this we ourselves implement the serialization. Now as we implement this, there would be no reflection use and hence no garbage collection, which is why it is far more efficient than serializable, and it gets around with some of the default problems of Java serialization scheme. Next question what we have is, what database is used in Android and how is it different from client server database management system? So SQLite is a database used, which is an open source relational database. Now it is SQLite engine is serverless, transactional, and also self-contained. Instead of client server relationship of most database management system, this engine is integrally linked with the application, and it can be called dynamically. It can be used to make simple functional call that reduce the latency for database access. Next question what we have is, what is the difference between service and thread? So we have already seen service, and in some context thread also. So we already know that service is an application component which runs in background to perform long running operations which do not need user interaction or the user interface. Now the thread is just a concurrent unit of execution which is dependent on what we can see the activity. Now it exposes few functionalities to other applications by calling context.bind service, that is the service, and then Google has brought in handlers and loopers to handle the thread properly. Now when the application is killed, service may or may not be killed, whereas in the thread, when an application is killed, the thread is definitely killed. Moving on, the next question what we have is, what is content provider and how is it implemented? So content provider is one of the primary building blocks of Android application, which manages access to central repository of data. It acts as a standard interface that connects data in one process with the code running in another process. So it can be used to share data between different applications. So they are responsible for encapsulating the data and providing mechanism for defining data security. It is implemented as a subclass of content provider class and must implement a set of APIs that will enable other applications to perform transactions. So it is implemented by name of the content provider and extends the content provider, which would basically have an onCreate method. Now, what is the significance of .text file? Android programs can be compiled into .text file, that is Dalvik executable file, by DVM, which are then zipped into an APK file on the device. .text files are created by translating compiled application written in Java. .text is formatted that is optimized for effective storage and memory mappable executions. Next question what we have is, what is the difference between compile SDK version and target SDK version? So compile SDK version is a version of API the application is compiled against. You can use Android API features involved in that version of the API as well as all the previous versions. For example, if you try and use API 15 features but set compile SDK version to 14, you will get a compilation error. If you set compile SDK version to 15, you can still run the app on API 14 devices as long as your app's execution paths do not attempt to invoke any API specific to API 15. Target SDK version indicates that you have tested your app on presumably up to and including the version you are specified. This is like a certification or sign off you are giving the Android OS as a hint that how it should handle your application in terms of OS features. For example, setting target SDK version value to 11 or higher permits the system to apply a new default theme, Holo, to application when running on Android 3.0 or higher. It also disables screen compatibility mode when running on larger screen because support for API 11 implicitly support larger screens. Question number 38 says that explain about Java classes related to use of sensors of Android. Now, sensors Android API provides many classes and interface for use of sensors or Android. The important classes and interfaces of sensor API are given below. So the first one is sensor class. This class helps you to create an instance of specific sensor. It provide method that let you determine sensor's capability. Then we have sensor manager class. This class is used to create an instance of sensor service. It provides methods to access and list sensors, to register and unregister sensor listeners. Then we have sensor event class. This is used to create a sensor event object. It provides information about the sensor event, including raw sensor data, the accuracy of data, type of sensor, and timestamp of the event. Next, sensor event listener interface. This interface is used to create two callback methods that receive sensor event notification when sensor value changes or when sensor accuracy changes. So these two methods are void on accuracy change, which takes sensor and accuracy integer, which is called when sensor accuracy is changed, and void on sensor change, that is sensor event, which is called when sensor values are changed. Next question what we have is, and basically it is the final question, what is a jobs scheduler? So it is an API used for scheduling different types of jobs against framework that will be executed in app's own process. So this allows application to perform the given task while being considerate about the device battery at the cost of timing control. Now, job scheduler supports batch scheduling of jobs. The Android system can combine jobs for reducing battery consumption. So job manager automatically handles the network unreliability, so it makes handling uploads easier. Now here are some of the example of situation where you would use the job scheduler. So tasks that should be done when the device is connected to a power supply, or tasks that require a Wi-Fi connection or network access, tasks that should run on regular basis as batch, where the timing is not critical. So that's all for this video, guys. I hope you enjoyed the video and this was helpful in some way or the other. So that's all. If you like the video, hit the thumbs up button and subscribe if you need more such content, and I'll see you in the next one.